I'd like to give you an introduction to galvanic cells. These are electrochemical cells that we're talking about here. In this particular instance, we've got zinc as one electrode in a solution of zinc sulfate, and we've got copper as another electrode in a solution of copper sulfate. We've got a wire connecting the electrodes, and then we've got this thing called a salt bridge here. I'll explain what that's doing in a minute. Anyway, let's look at what's going on in the actual reaction. We've got zinc, which is a metal, and it has a charge of 0. So when zinc has a charge of 0, it just looks like this. And it's turning into zinc 2+. And you can see the difference here. The zinc 2+ is an aqueous solution. And what's happening is the zinc is actually giving up 2 electrons when it's forming zinc 2+. Those particular 2 electrons, those very 2 electrons, are going to be now taken up by the copper 2+ on the other side of the solution and turned into copper. So you can see the difference here between copper 2+ and copper. Copper 2+ being a liquid, an aqueous solution, and the copper solid being a metal. Alright, so let's go back and take a look at that on the diagram. Alright, so you've got your zinc here, and the electrons are being transferred through the wire to the copper. Now it's these copper 2+ here that are accepting the electrons. And you can see what's going on is that the copper 2+ are actually turning into copper, and we've got copper plating on the copper electrode. So when we pull this out at the end, this electrode is actually going to be fatter than what it was when we first put it in. Now the zinc, on the other hand, is dissolving. It's turning into zinc 2+. And that's because it's losing the electrons, and the zinc is turning into this zinc 2+ here. Now I said that this was a solution in zinc sulfate, and that's a solution in copper sulfate. So we've got all these negative sulfate ions floating around. What's going on with those? Well, if we've got copper 2+ over here, and that copper 2+ is disappearing because it's turning into something that's not charged, then it's not going to need the negative ions anymore to counterbalance that charge. Those negative ions have got to go somewhere. Coincidentally, the zinc is dissolving into zinc 2+, so we're getting more zinc 2+s over here, and they will take the ions that the copper 2+ was using, and those ions will travel to the zinc side via the salt bridge. So the salt bridge purpose is to even out the negative charges in the reaction. The other way of looking at it is you've got electrons, negative charges traveling through the wire. In order to make up for that, negative charges will travel in the opposite direction via the salt bridge. If we didn't have a salt bridge here, the reaction just wouldn't go. It would just sit there and look at you. Nothing would happen. So it's definitely necessary to have a salt bridge present in the process. Alright, let's look at some of the other processes that are occurring. We've got oxidation is loss of electrons, reduction is gain of electrons. We can remember this by the mnemonic oil rig. So let's look at what's going on with the actual reaction. We can see the zinc is giving away the electrons. We know this because the electrons are on the product side, and this is definitely oxidation going on here. The other way that we know that oxidation is occurring is to look at the charges on the zinc. Initially the charge on the zinc is 0 because it's a metal, but now it's becoming 2. So if the charge is increasing or going up, then oxidation is occurring. Now down here we've got the copper 2+ turning into copper. That's a reduction process, and the electrons are on the reactant side. So anytime you see the electrons on the reactant side, that's a reduction. The other thing that's happening here is we're going from a charge of 2 to 0. So the charge is going down or is being reduced. That's where the name reduction comes from, because we're looking at a reduction in charge. And the reduction in charge is happening because electrons are being added to the copper 2+. Alright, let's look at one other thing here. We've got two parts of the electrode, one we call the anode and one we call the cathode. The anode is the electrode at which oxidation is occurring. The cathode is the electrode at which reduction is occurring. And the way we can remember that is anode and oxidation both start with a vowel, and cathode and reduction both start with a consonant. So that's a good way to remember that. So as I said, the zinc is turning into zinc 2 plus. That's oxidation. Alright, so the zinc turning into zinc 2 plus, that's oxidation. That's occurring at the anode. And the copper 2 plus is turning into copper, and that's a reduction, and that's happening at the cathode. Right, so just showing you again, anode over here, a cathode over here.